Well, hey everybody, my name is Paul Laverty. Welcome to another episode of Electrical Blunders. And today we're going to look at wiring up a basement. Now, this is a video that's shared quite a few views, and it does provide some good information, but we're going to take the time to look at it, critique it, give you some other advice, and make different suggestions along the way. Again, we're not here to berate, belittle, to put down, we're only here to add additional commentary, correct things that might be misleading, maybe make your installation a little easier for you by giving you tips and tricks and different opinions on the installation. Again, we're not here to belittle, we're here to add benefit to it. So this video is about 30 minutes long. Of course, with my commentary, it'll be a little longer, so be prepared for that. Hopefully you watch the entire video. And I've got my headphones. I'm going to listen just like you. I'm going to add my commentary, and we're going to get into it. So without further ado, welcome to this edition of Electrical Blunders, as we're going to look at wiring a basement. So let's go on and get started on that, and I'll get my headphones on. All right, so this is a basement bedroom, okay, but it isn't a basement. And so again, it's kind of two things, with basement being refinished, or finished off, I should say, and we'll be looking at bedrooms, so keeping those things in mind. So let's go on and get started in it, and let's see what we can add as commentary to this video.
This is the master bedroom of the basement development we're working on. I'm going to show you how to do the rough-in electrical.
I'm excited.
We've got planned for one light switch, 2 lights, and 5 plugs. The reason why I'm showing you the bedroom is that with the bedroom, you need an independent breaker, an arc fault breaker. So it's something that I can show you kind of all in one setup.
Now, I should remind you, starting out, you're not required to have a individual branch circuit or dedicated circuit to the bedroom. In other words, I could hit 2 bedrooms if I wanted. However, he is correct that it would require arc fault circuit interrupter protection in accordance with 210.12a, because this is a bedroom, and that is listed in our laundry list of locations, that the circuit itself, the entire circuit, has to be protected with AFCI protection. Now, I say the entire circuit because there are allowances, depending on the length of your NMB, that I actually can have a circuit type of outlet AFCI installed at the first receptacle location. So there's our allowances in 210.12a, but most people are going to simply put it in the panel, and they're going to supply everything downstream with AFCI protection. Now with AFCI protection, real quick, I'll tell you there's what you're going to have is a requirement for it to be a combination type AFCI device. And a combination is looking for both series and parallel arcs. Now what are those? So series arcs are series where you might have an individual conductor that's broken, or you have a weak termination at a device where the arc occurs when there's load going through the system. That's a series arc. Parallel arcs is what you might get when you drive a staple too far and you have a damage between an ungrounded hot conductor and a grounded neutral conductor in like an NMB, a black and a white. And that arcing is not limited by the load, but it's across the individual conductors. That's parallel. So a combination AFCI is looking for both series and parallel arcs. Okay, now you might be familiar with what's called a dual function AFCI, and that is a dual function is looking for the AFCI characteristics, but also has the benefit of GFCI characteristics as well. So it meets double. So that is called a dual function. Just remember, a combination AFCI has nothing to do with GFCI. It is simply looking for the 2 different types of arcing characteristics. Okay, so just wanted to lay that out as we get further in, but you aren't required to have any dedicated circuit to the bedroom. But you are required to protect that circuit, that branch circuit, with AFCI protection.
Rather than going through the basement and showing you a bunch of confusing stuff, the bedroom is kind of gets done with one breaker, brought back to the panel, tied into an individual breaker. So let's get started. I'm going to, I've got my pen here, tape measure. I'm going to do a layout for where I want my plugs to be. I'm going to get the
receptacles,
vapor barrier and insulation out of the way. Mount my boxes everywhere that they're going to go, and then drill
outlet boxes,
pull my wire, and should be done what I need to do. This door here is going to swing open this way, so I've got a perfect location here for some switches.
Smart move.
I like the top of my boxes to be at 42 inches.
A little low to me. I like about 50 inches, but okay, it's fine.
42
42 inches is fine. A little low. Looks like a tall guy, so maybe it's not his house.
Myself a little felt mark for the switch. Now, my local
incidentally,
would suggest
when you put your box, in his case, he's using 42 inches, but I tip to use 50 inches because it's a nice round number, and it works also for countertops as well. And it keeps everything consistent when you all have a consistent height that you want to do these things at. But you can go to the top, the middle, or the bottom of the box. As long as you're consistent, it doesn't really matter. Most of the time I go 50 to the top, but it doesn't really matter how you want to do that. Now, receptacles, I usually do 16 inches to the top, but there's some people that do 18 inches to the top. It's totally up to you, but just be consistent with how you lay it out around the room.
That I can't have any receptacles or plugs, as you know it, further than 12 feet apart. In this layout, for convenience, and I suggest this for anyone viewing this, that it's better to put a couple more in than not have enough. The worst is putting a bedroom in with a nightstand and not having a plug there, running extension cords.
I will give you a little hint. So his statement about you can't have a receptacle that's more than 12 feet apart is so that any point in the wall line, you can't be more than 6 feet from a receptacle. So that's where we get the 12 foot. So you hear us talk about this rule in the code, and in real life as electricians, we say 6 foot, 12 foot rule. That's because you have to have a receptacle within 6 feet of any wall opening. In that case, he's got a door. So he's going to measure 6 feet, and he can have a receptacle anywhere in that 6 feet. And once he gets to that 6 foot, then he could go another 12 feet. Why? Because if I were to touch anywhere on that wall between the 12 feet, I'm going to be within 6 feet of a receptacle. And that's what that rule is. So that's why we call it 6 foot, 12 foot. But he's going to have one within 6 feet of that door opening to be his first one. Now he can adjust that. Maybe he's only 3 foot away so that his next one is positioned properly so it's not in the corner. That's totally up to him. Okay. So again, all about your layout and your design.
So I'm going to go a little closer than you normally would go. Basically, I'm going to start with my first plug right here on this. And I like
it looks like about 2 feet, 2.5 feet.
16 inches to the top.
So he's doing 16 to the top. Perfectly fine.
There. Now, here's what I'm talking about.
Now he can go up to 12 feet to the next one. But it might mess up his
12
layout.
feet is further than this length of this wall. So I technically don't have to put a plug in until around here. But
That'd look funky,
for
wouldn't it?
Convenience, I'm going to add another one right on this stud here.
So, if you're doing it yourself, think about how your layout's going to be, how your furniture going to be positioned. You don't want a receptacle that's jammed in the corner. It might mean that you add an additional outlet box for a receptacle, more than you normally would need to meet the minimums of code, but that's okay. Again, it's all about layout and it's all about convenience to being able to get to that receptacle. So it might mean that you don't go all the way to the 12 feet. It might mean you only go 8 feet and you put another one. Again, it's okay. 12 is the maximum between receptacles. Okay. And remember, it has to be one within 6 feet of an opening, like a doorway or a break in the floor line, which he already has. He's putting one at about 3 feet. Perfectly fine.
Again, pull up my tape measure. Mark the 16 inches for the top. Okay. Now through here, because I've got the vapor barrier, we've obviously got to pull this vapor barrier out of the way, get the insulation out of here so that we can do our marking layout and drill our holes. So I need to grab a knife. Okay, so in our electrical layout, we're here at the exterior wall where we've got our insulation and vapor barrier. We need to remove the plastic out of the way as well as the insulation so that we can get the wiring in there. To do so, just grab your utility knife. I like to stay a couple inches off the ground. When I repair this back in, I'll use specified tape to retape the vapor barrier.
All right, let me make an observation here. He is getting ready to create more work than he needed to do. He could actually go to the bottom of that wall and pull that vapor barrier away from the wall and bring it up and then tack it up high rather than cut it. Because when he cuts it, now he's got to tape it. He created more work for himself. So I would have pulled it loose from the bottom, pulled it up, and then I would have either tacked it up higher so it gives me the room down low, rather than cutting it. Because the moment that he cuts it, now he's going to have to patch it. And I would have pulled it up so that when I laid it back down, I could just take a hand stapler or a banger, we call it, and I would just go through there and bang, 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 and put the actual vapor barrier back. But now he's got to go through all this taping. So again, it's just live and learn. I would have pulled it from the bottom and pulled it loose and folded it up, opening up so that I could do the work rather than cutting the vapor barrier. That's just me. Okay, he's creating a little more work than he needed to do.
Back together so it's acceptable by code standards, and go from there.
Say I would have gone to the bottom and just pulled it up. Because all it is tacked to the bottom.
This will be the final location of my last plug, so I don't need to cut any of this out. But now that I am flipping it up.
So now, in all fairness to him, if that bottom is really, really sealed and maybe it's awkward to reseal it, then maybe that's why he's cutting it at his height. But again, ones that I've done, I just peel it up. But again, in all fairness, I don't know his install. So in all fairness, it could be sealed really well at the bottom and he just doesn't want to break that seal. So he thinks it's much better to just cut it and then pull it up and then tape it. That's his design. That's his choice. Okay. So I don't want to make anybody think that I'm just slamming on the gentleman, because again, his installation is different. He's doing what he thinks he needs to do. I'm just saying in my case, it's easier just to peel it back and tack it down later.
I'm going to cut on the stud. To about the height of where the bat line is, and now I can put this Now that we've got our vapor barrier cut and able to pull up, I just grab my hammer tacker, stapler, and just gonna
tack it out of the way.
Tack this poly.
All right, we'll kind of speed up a little bit on that process. Sure. So now he's laying it out.
Red. I'm gonna add another one right here.
Again, he doesn't have to go 12 feet. Whatever looks aesthetically pleasing and for how the layout of the room might be, it's perfectly fine. Now, he could go from that last one up to 12 feet if he wanted.
More right here.
Very rarely laying out a room do we go 6 foot, 12, 12, 12, 12, 12. Very rarely do we do that because of the aesthetics and where that receptacle might end up laying out is awkward.
Right here. So now that I've got my 5 receptacles laid out, I'm going to proceed with mounting the receptacle boxes so that when I drill my holes, I'm not drilling any holes interfering with where the boxes need to be mounted. Okay, so this is the box I'm going to use for the light switch. It's identical to the boxes I'm going to use for the receptacles.
Again, I'll make an observation. I guess depending on where you're at in the country, he's using metal boxes. Again, I would use non-metallic boxes, but maybe there's a shortage of plastic boxes or something. I don't know. Carlon makes a lot of them. I don't know. But again, when you use metal boxes, you're going to have to bond the boxes with the equipment grounding conductor. It's a lot more things you have to do than if you just do a simple nail-up box. So again, if you can get the nail-up boxes at your Home Depot or your Lowe's or whatnot, go with the plastic nail-up boxes. Makes life a lot easier. But can you use metal boxes? Absolutely. That's your choice.
I'm just going to show you a quick review on how to install it. So they've got some holes on the inside so that you can put some screws in on that angle. What I like to do is put the ones in at the top here, so, and one in the bottom. So stick your box on your line, hold it with your thumb. Your drill handy.
Had it been a nail-up box, you just pop, pop, done. Just saying. Some people just like the metal boxes, so it's okay. Perfectly fine. No violation. Perfectly fine to use a metal box if you'd like. Just going to have to bond it with that equipment granite conductor.
All right, and that's a firmly mounted receptacle box.
Switch box.
This is an exterior wall where we have the vapor barrier and insulation through it. When you're mounting a receptacle in that wall, it needs to be vapor barrier protected in a sleeve as well. So what I do is, this is a poly pan made exactly for this size box. Set it in its rough location and put a couple staples in it, and then come into here. And this is where those inside mounting screws that you saw earlier come in handy, because I could just go inside the box, installing it that way rather than having to try to pull the plastic out of the way to get the screws in.
Yeah, just remember, you're doing this to maintain the vapor barrier as an energy code thing. You're still going to have to get those cables into that box, through that barrier, into the actual box, through the connector. It's going to be a little bit more difficult with this on there. So again, you're going to have to make sure that you're making your holes in your barrier, that you can get the cable down into the box. Okay, so just keep that in mind in your planning. He's putting the box up. He's obviously he can poke a hole in that protector there, the barrier. You can do that, but I mean, things you got to think about. You got to get a cable into that box still.
And there you have it. Poly pan in. When the vapor barrier comes back down, I'm able to seal around this, creating no air loss between the electrical box and the poly pan. Next, we're going to go finish installing the rest of the boxes throughout the room and get ready to start drilling.
Okay, let's kind of get to about right here.
Okay, so this is an octagon box. It's meant for lighting and has several other uses, but in our case, we're gonna use it to put up our rough-in for electrical light. So here's our indicator point, creating from center to center and center to center. So using the same screws as before. Hold up the box on center. All right, nice and strong. Got one more light on this side, so exact same thing.
I will make an observation for you. If you're in the 2020 National Electrical Code and you have lights that plausibly could allow a ceiling fan because there's no restriction on the blade spinning and things like that, then you're going to have to use a box that's going to be a fan rated box. Okay. Even though in your mind you're thinking, I'm never going to put but a luminaire in here. When you look in the National Electrical Code, it has changed, and it says, look, if the location you're putting this light box in is plausible to be able to put a ceiling fan in there because there is no restriction on the blade spinning, then it's going to have a box that's rated to be a sole support of a ceiling fan. Now, you will notice that this is in between floors, so there are allowances to not have to do that if you had access to it at a later date above the ceiling and things like this. This is a closed floor, so this tells me this is in between floors. So he would have to use a box that is rated to support a ceiling fan based on the 2020 National Electrical Code. So keep that in mind. Check it out. These boxes, I don't believe, are rated for that. So again, just things to think about in your installation. You just don't throw up a light box when you think about, okay, is the location plausible for me able to put a ceiling fan or somebody to put a ceiling fan on? If it is, then it has to be a box that's designed to support the ceiling fan. Okay, just kind of things to think about as you're doing your installation.
Here's our indicator point. And there we go. So we're complete with boxing out our room. So we've got a switch, 5 plugs, and 2 lights.
Oh, I should mention, if you're a code geek like me and you want to read that new rule or the expanded clarified rule for those ceiling fans to support paddle fans, then you want to look in the code at 314.27C, and you'll have a 1 and a 2. Okay, so you've got some allowances there. But again, if you're putting luminaires in a ceiling and you're putting the ceiling outlet box, and it plausibly could have a potential ceiling fan installed there because there's no obstruction to blades, then you have to think about this rule. And so I just wanted to make sure I call that out. So again, for those taking notes, 314.27 C1 and 2. Make sure you read them if that's the installation you're doing.
Next procedure is to bring out our drill, start drilling through the studs so that we can pull our wires through. Okay, so now we're ready to drill out for the wiring to go through the studs. This is a screw tip auger bit.
I love how he's taken his drills and he's coded them so no manufacturer can be referenced in his video. I love it, you know. Again, now we do this critique under the Fair Use Act that is afforded us. But in this case, he literally has blacked out all of his power tools, so no manufacturer gets any reference. I love it.
The screw tip goes into the wood and actually pulls the bit with it, so it enables quite a bit easier drilling. Can be picked up at any local hardware store. So here we go.
Wearing goggles, I love it. Even putting ear protection on. Go figure. There you go. Now drill through the center of the stud. You want to make sure that you're not less than 1.25 inches from the edge of the board hole to the edge of the framing member on either side of the stud. Okay. And he's keeping his holes about as flat and horizontal as you can. That's good. When you're doing these angle holes, they're the ones you have to be careful about maintaining that 1.25 inches from the board hole. Okay. They're the ones that you have to be worried about. Keep it in the center of that stud, my brother. Oh, right into a knot. He made it look like a piece of cake. All right, so the next thing that he's going to encounter is that he's got stacked studs at this corner here. And that's going to be a challenge for him. One of the things that I do with this is I'll drill from one end in and I'll drill from the other end in, and then I will actually drill a series of holes in the center of the two, in that corner, as a guide hole, so that when I'm pushing it through one, I can help poke it around the corner, because you can make that turn, okay? You just have to be careful when you're drilling in, because this is a location where on the right side of that window, under the window, he's got another stud there. He's going to have a hard time keeping it as it bores in there. It's going to have to be at an angle. So what he's going to have is he's going to have straight in from the left side over here. It's probably not a problem. On the right side, it's going to be at a bit of an angle. So I like to drill a series of pilot holes in the middle, so it's kind of a peephole, so I can make sure that my two holes come together so that I can kind of work it, curve the NMB, and work it around the corner. Now, if any time any of these bored holes are less than 1.25 inches, whether it's on the back side or the side that's facing the room, then I want to put a nail plate in there. Because again, I don't want somebody from sheetrocker to come, and you know they don't always use the right screws they're supposed to, or the right nails. I don't want to risk it. Okay, so this is his first challenge when it comes to drilling.
Okay, so now here we have a situation where we couldn't keep drilling because it's going to come into the window. So we're going to drop the elevation of our holes and carry on through. I want to just show you the height of these boxes. Doesn't allow a lot of space up here to drill the holes either, so I'm likely going to pull the wires underneath these boxes through this section where the window is, and then jump back up for the rest of it.
Now see how close he is here? And
also, a nail in there, so
Also, you see how close he is on the other. I would have been more in the middle, and actually from maybe even from the other side of the wall, kind of at an angle in a little bit, just a slight little bit. It helps for your fishing. So he could have gone in the other room and done that. It does look like he dropped down bit sizes. This is an example in the corner like that, where I use the maximum size bit that I can, that's still going to allow me 1.25 inches from the perimeters, from the edge of the hole to the actual edge of the frame member on either side, because the bigger, the little bit better it is to maneuver. You're going to get some pieces of wood flakes that stay in there and kind of inhibit the pushing the wire around, or the cable around, excuse me. So that's occasion where I might go a little bit bigger. In order, that's kind of like a professional tip. But most of the time, our auger bits that we use are pretty decent. It doesn't really require that. But again, that's going to be his first challenge. But again, have those nail plates ready, because any time that you're going to be less than 1.25 inches from the edge of the board hole to the framing member edge, you're going to need a nail plate, 1/16 of an inch steel nail plate.
Sometimes you got to make some adjustments, and
he does look like he has a cavity gap in there, so that might make it a little easier. There you go. I saw this move. Stay in that center of that stud, though. Don't break away from your plan. Now I would have drilled this from the other side, because there's a little more room to get the actual drill in there and keep that hole in the center. Because you don't want to come out on the other side less than 1.25 inches. Then you got to try to knock the points down on the nail plate and get it behind there, because that's what the code says. Now it looks to me like he's got, look, these aren't 2x4, these are 2x6s, so he's got plenty of room to work with. So he's okay. Many times we don't have that luxury. It's simply 2x4 walls, and you got to be real careful.
okay, so we've got all our holes drilled now. We're using a 14-2 Lumex wire. I'm going to start by fishing it through some of the holes in the TGIs, or the floor joists, at the panel location, bringing the wire to our first switch box, and continuing on through to all the plugs. What I've got going on here is I hang my wire reel so I can get my wire quite easily, rather than leaving it on the ground and trying to uncoil it all apart.
I've never heard of Lumex. I'm just saying. Never heard of that name. Oh, I don't like that bundling right there. We won't get into that topic for today. That's existing. We won't get into that fact that he's using like a 2-inch EMT strap, 2-hole strap to do that. We won't get into that today's episode. He's not installing that, so
wire reel attached to the wall there. I started at our panel, up through a hole in the floor joist. Started coming along this joist here. I'm going to be stapling it along this beam, all the way to here. Then you can see the wires loop down, going towards our switch.
So what he's doing is he's bringing his home run
at our switch location
to the switch location, and that's the point where he's feeding his room, okay, with this home run.
And bringing it all the way back to our last plug. Now what I'm going to do is get my staples. These are electrical Lumex staples. Now this has got a S2 on it.
Now this is making me think that this gentleman is also in Canada, because I'm not familiar with that name of that non-metallic sheath cable, so it sounds very Canadian to me. Those staples are what we saw in a previous video that talks about being, it was a Canadian video as well. So again, I am taking videos and critiquing them based on the National Electrical Code, not anything to do with the Canadian code. So don't want to hear anything about that. Electrical is electrical, but I am feeding you what the National Electrical Code says in all of these installation ideas.
On it, that's meant for stapling 2 wires to the stud.
2 cables.
This one's got a S1. So in this situation here, where it's just one wire,
cable.
I'm just going to use that S1.
We all know what he's saying. Now let me give you something else real quick for you. Since you're not using a nail-up plastic box, which doesn't have a clamp built into it, it's just a nail-up 2 1/4 by 4 inch nail-up box. He's using a metal box. This metal box does have an interior clamp. Because it has an interior clamp, then that cable can go from that clamp up to as far as 12 inches before he has to put that staple in. If that had been a nail-up plastic box with no clamp built into it, then he would have to have secured that cable within 8 inches of that nail-up box because it doesn't have a built-in clamp. This one has a clamp, so he can go as far as 12 inches. Right here, it looks like he's about 6 inches or 8 inches, which is perfectly acceptable. You can't exceed 12. He's perfectly fine.
Tack it on like that. That'll be my service loop. And this is a long enough wire to do what I need to do.
Now remember, he said service loop. I think he's just being theoretical, is servicing the receptacle. But that loop in our codes, in the National Electrical Code in 334.30, while the staple has to be, in this case, could be up to 12 inches away, from that staple to that box, you cannot have more than 18 inches of cable as it measures along the cable. Okay, so you can't have this real big loop. It's limited in the 2020 National Electrical Code to only 18 inches. So you can have a little bit of a loop there, again, for later adding, getting more wire, if you have more cable if you want, but it can't be more than 18 inches. So just keep that in mind. And that's under 334.30 of the National Electrical Code. Almost the last paragraph in the charging statement of Section 30 makes that statement. And that is new for the 2020 edition of the National Electrical Code.
So from here, I'll carry on. So from that plug, I come back to this one.
Now also remember, since he's running horizontally, that he does not have to secure and support it. It's considered secured and supported because it's running through board holes or framing members. Okay, that doesn't apply vertically. That only applies horizontally. So as far as he's concerned, everything's secured and supported, and he could go up to 4.5 feet between securements. Well, since these studs are probably looking like 16 inches or 18 inches on center, then they're well within the 4.5 feet. So he's perfectly okay running them horizontally through the framing members without securing them at any point until he gets to the location where he turns vertical to come down the framing member to get to his box. Then he has to secure it again up to 12 inches from the box because he's using metal boxes with built-in clamps. Okay. If it was a plastic nail up with no clamp, he has to secure it within 8 inches of the point of entering into the actual non-metallic box. Just things that you should know.
It's right here. Now this is where S2 staple comes in handy. So I leave enough wire. I'm going to staple it to the side, and I leave enough wire. See how that wouldn't be enough, right? So I've got to...
Well, it would be enough, probably, because you don't have to have that loop on it. I mean, you could come down and straight into the box, coming straight out of the board hole and straight down the side and bring them both into the box. It's perfectly fine. You don't need this loop. And if people say, well, I want this loop for a receptacle to be able to come back later, why would you be coming back later? You probably, once you put this receptacle in, it's one and done. So the loops to me for the receptacles like this is a waste. But since I work for a manufacturer that makes cable, heck, man, do the 18 inches on every one of them. Again, we sell more cable, we make more money, okay? But at the end of the day, the loops aren't necessary for this application.
Got my service loop and my extra wire. So that is enough wire.
Look, his hammer's even coated, so nobody knows what brand it is. Beautiful. Remember with driving staples, folks, these staples have a little bit of a guide on it, so these are not bad. Again, I don't think I've seen these in the U.S., but but at any rate, when you're driving staples, you do not have to drive it so that the staple embeds in the sheathing. Okay, remember that white there, that is sheathing. It's not insulation, it's sheathing. It's a protective covering that's extruded over top of the individual conductors inside of it. Point being is you only have to drive a staple until it touches the sheathing or a little bit shy of touching it. You're just trying to keep it in the middle of the framing member. You're not trying to embed it into the framing member, okay? Save yourself a lot of problems. Don't overdrive your staples.
And there we go. So I'm going to go through the rest of this room, doing the same thing with the stapling, all the way back to the panel to get all the wires neatly tucked into the spaces, and then we'll go through cutting these wires into the box. Okay, so what I'm going to do now is, here's a 14-2 wire. I've got my home run feed from the panel going into the switch. Now I've got my out to the plugs heading that way. Now I'm going to run this wire to the lights and to the second light and back to this switch. So I'll have 3 wires at this switch, one going to the panel, one going to the plugs, and one going to the lights.
Now, incidentally, for everybody wondering, one of the things that people have to take into consideration is box fill. Okay, so he's running 14 gauge. In the National Electrical Code, 314.16 is where you're going to go when you're doing box fill calculations. So in his case, he's got 3 14-2s that are going to be coming, and he's going to have a switch. So he's got 3 blacks, 3 whites, an equipment ground, and a device that equals 2 conductors. So he's got 1, 2, 3, 4, 5, 6, 7, 8, 9 conductors. Okay. At 2.00 cubic inch for 14, if you go look at the table in 314.16a, then you need to make sure that your box cubic inch can handle that many cables. Now, this one probably can. It's not that big of an issue, but just think about it. And that's why you have to be aware of the cubic inches in a box. Okay. And you have different boxes. We have even nail up plastic boxes that can be as little as 17 cubic inches, 19 cubic inches, 22 cubic inches. All of that matters. Okay. So again, box fill, hugely important, making sure you're not overfilling a box. And I'll also mention, you see how he's going through those top plates? In most jurisdictions, you're going to have to seal that top plate anytime you drill through a top plate or bottom plate because you need to maintain the rating of that assembly. So 300.21 of the National Electrical Code talks about maintaining the rating of that assembly and to stop the spread of the products of combustion. Okay, so you allow air to get into it and it can fan the flames if a fire starts in that cavity. So again, most jurisdictions, you're going to seal that top plate and bottom plate. Don't require you to do the horizontals, but they do require you to seal the top plate. Okay.
All right, here we are. The light. So I'm just going to get some S1 and S2 staples again so I can start stapling at our last location, which is this light. Staple back to the second light. And then
got a lot of slack on that bad boy. I like him. He uses a lot of wire. He just wants to make sure he has enough. It's no worries. Again, remember what I said about boxes. In the U.S., okay, be aware, okay, whether or not you're going to have to put a fan box up there. Hey, he's speeding up, so I don't have to do it. All right, just clarity. He's doing a little different than I would do it. Again, everybody's different, but he's doing a lot of these loops so he can staple it up. personally, I cut in everything as I go back so that I don't staple until I have everything cut in, and then I put the staple on. Okay, so I pre-strip my sheathings and I put them in the box, and then I staple so that everything's nice and neat. He's just pulling everything and looping it, and then he's stapling it. That's fine, but I find that this takes a lot more time because now he's got to go back to everything and trim it out. I was already there. I want to trim it out while I'm there, and then I staple everything as I go. Again, 6 of one, half a dozen of the other, but again, to me, I was training my helpers. This would be the most efficient way that I would do it. Again, it's not that it's wrong. It just wouldn't be the more efficient way that I would do it. Everybody's got an opinion. I get it. See, I'm right there. I'm cutting that box in. I'm right there already. I'm cutting that thing in. Okay. Look, his ladder's even coated.
Now, no stapling required through here. Just have to snug up the line. And back to here. Now in this situation, because we got a skinny 2x4, I'm going to use, I've used S1 staples to staple down through here. I'm just going to use a S2 staple and go right over both of the wires. And that way I'm keeping it nice and tidy.
That's just another example of when I'm pulling all the wires and you start cutting everything. I pull everything and I'm cutting it all in. Then I wouldn't have to do staple on top of a staple type of thing. I mean, I would cut it all in and then I would be secure. And as I'm cutting, I'd leave the wires hanging. And now the moment I cut in that switch box, then I would do my stapling. And then I would just use one staple. So he's using some extra staples. That's okay. But again, it's nothing wrong with it. It just takes a little more time. I love the coated hammer and drills and everything. I mean, now how will you know? How will I know that this is Canada? Is the moment that he strips that NMB, if it doesn't have paper in it, then we're pretty sure that it's Canada. Okay, I'm just saying.
Notice here is I don't want to make my service loop here and come through here because I've only got 2 holes at the top to put these 2 wires through. So I'm actually going to run this wire down below and come up through the bottom.
I'm actually liking those staples, to be honest with you. I would imagine they're pretty expensive, but I'm actually liking them. Remember now, loops, okay? But can't be more from that securement up to the box more than 18 inches.
So now we're here at the switch box. This has got 3 wires, as we spoke of earlier. One's the home run feed for the power from the panel. Okay. One's going to the plugs, and one's going to the lights.
Luminaires.
Gonna strip about 6 inches of wire. Now, I know that this is roughly 6 inches long, this body of the knife. So I just...
Look at that. The knife is even coated so you can't see the manufacturer. Dude, he's been in trouble before somewhere. That's why he's doing it.
Snip it back. And just...
Oh, be careful.
Go into the jacket a little bit. Like you don't have to push hard to get through the jacket.
Be careful.
And then you can pull it off just like that. Nice clean cut. Now, I really like to match all my wires so I can line it right up with the last one I did. And again, the ground wire is right in the center, so that's how you know you're not going to slice these wires. You got to pick the center of the wire, you push your knife through. And
don't like that method of stripping. Sorry, just don't like it. I don't like that either. Pull the wires up, go underneath it, cut away from the conductors, cutting that sheathing away. Don't like that cutting into it. You could put little micro cuts in there, and again, could cause a problem. So I don't like that. That's just me. Sorry. There you go. Cut the other side. You should be fine.
There we go. Those are the wires that I'm gonna feed in through the box and have sticking out. I just want to explain the service loop now. When I put these wires down through these holes, There's a couple of clamps inside there. You want about a quarter inch.
And remember that box fill thing we were talking about? Those clamps also equate to one conductor as well. So now the rules have changed. So because of this box not being a non-metallic, being a metallic, he's got a 2.00 because it's a 14 gauge volume. Again, 314.16a. Look at that table. And so he's got 3 blacks, 3 whites, an equipment ground, which all count as 1 because he's only got 3 of them in there. So in the 2020 code that changes, but right now he's only got 3. So he's got 3, 6, 7 for the equipment ground, 8, 9 for the switch, and then he's got clamps in there. And it doesn't matter if he's got more than 1; it just counts as 1 volume. So then he's got 10. Okay, so again, 3 blacks, 3 whites. The equipment grounds count as 1. His device, his switch, counts as 2 volume count, or 2 conductors, if you will. And those clamps in there count as 1. So now he's got 6, 7, 8, 9, 10. Now 10 times 2.00, which is a cubic inch value in 314.16a, is going to tell me he's got 20 cubic inches of wire, so he needs to at least make sure that box can handle 20 cubic inches of wire. Now, we don't account any space for wire nuts. We don't count any space for pigtails, just what we've got. So keep that in mind. That's why you have to know the boxes you're working with. If that was an 18 cubic inch box, he's screwed at this point. Just saying.
Of the jacket to stick past this clamp when you tighten it down. Now, if during drywalling or any other procedure throughout the construction where one of these wires gets nicked or broken and there's not enough to hook up the device to it, they can loosen the clamp and feed more of this service loop.
Oh, by the way, if you look at table 314.16a, and remember I said the volume, that's actually B. That's the one where you do the volume. A, since he was using a metal box, that's why I alluded to it. If you look at it, and I don't know what size that is, but that looks like that might be a 3 by 2 by 2.5 or something like that. If you look at the volume in cubic inches, the maximum is 18 inches. We've already counted 20 cubic inches worth of conductor in there. So if we were getting nitpicky, I don't know the cubic inches of that box, but it seems to me like he might be exceeding the cubic inch. I'm just speculating, okay? But these are things that you need to think about.
Through to be able to get another 6 inches of wire to be able to attach to. So, service loop, good idea.
As long as it's not longer than 18 inches, you're fine.
So there's always these tabs on the box. You just take off the ones you're going to use. In this case, I'm using the 2 at the top.
Now you'll notice that that metal box is actually a gangable box. So it could be made into a 2-gang if you need it. So if he had an issue and some inspector really slammed him, then he could remove that and put another gang on it and make it a 2-gang box. Now he doesn't need a 2-gang, but if he needs to get on with his install, he needs more cubic inch space, that is what he could do. Okay, so he's got solutions. Okay, just be aware of that.
And one at the bottom. I'm going to start with putting this bottom one in since I'm down here.
Now you want to carry that sheathing into the box 1/4 of an inch past the clamp. Okay, that way the clamp binds down on the sheathing and not the individual conductors. And we'll assume he's doing it.
What I'm doing there is just tightening the clamp down onto the wire. Just snug. You don't need to pinch it in there too tight.
And that rule is 314.17b2 in case you wanted to look it up.
Hook up my ground to the ground screw right away. You can have a look in there. So you can see right there I've got the 3/16 to 1/4 inch of jacket sticking through. And I've got my
1/4 of an inch minimum
bare line, the ground wire on the ground screw. Now, whenever you're
please make sure you leave enough of that equipment ground
wires onto screws or
6 inches
or twisting on morettes.
Don't cut it off too short, fella.
Always go and put this around in the clockwise direction, which would be the way I'm tightening it down. If I put the wire around the other side and then I tighten it this way, it's gonna roll the wire off the screw, not enabling me to get this nice of a hold. So, okay, so
now,
that's the bottom one.
Let me talk to you a little bit about theories. There's some people will say that, again, if you look at the National Electrical Code, it'll say once you bond that metal box with that equipment ground, you're done. As long as the switch that's going in it is a self-grounding type and it actually bonds to it and the strap actually makes contact, then you don't need the jumper to the equipment ground terminal on the switch. Again, following all those rules in 250, 146, I believe, as well as following the rules in 404.9, I believe, maybe 9B. Follow those rules, then you have allowances here. But let me tell you something. The rule in 300.14 says that you have 6 inches of conductor from the point it leaves the sheathing. That applies to all conductors. Okay, so whether or not you immediately hit that terminal in the back of that box for that equipment grounding conductor, again, you don't get around the rule that says that all those conductors that are free, that are coming into the box, have to be at least 6 inches long. Okay, so that's a general rule. Now, when you have boxes like this that has in any dimension across the front, whether it's left to right, diagonal, any of them that are less than 8 inches, then you also have to make sure that when you outside of the front of the box, that I have at least 3 inches of conductor. Okay, so minimum 6 inches from the point it emerges from the sheathing, I have to have free conductor. That applies to the hot conductor, the neutral conductor, and the equipment ground. And I also have to make sure that it extends at least 3 inches beyond the front of the box if any dimension of the box is less than 8 inches. Okay, so you got to have adequate amount of conductor. Don't cut those equipment grounds off.
Okay, get those sitting equal.
Now, if you use plastic boxes, no bonding required to the box, but you still got to go to the screw of the switch, okay? But you don't have to bond the box because it's plastic. He's using metal, that's okay. A little more work with the metal. Now, this is an example where if you leave your conductors too short, it really makes it hard to work things out, okay? Even his screwdrivers are coated. Boy, he really doesn't want to give any props to any manufacturer, that's for sure. It's all good. Now, incidentally, it looks like he's trying to make all of the equipment grounds on the screws in the back. He would only have to do one, and then leaving that length of that equipment ground long enough, then he can connect them all together and twist them all together with a wire nut, rather than try to work so hard to get them all around a screw in the back. Okay, as long as one's around it, it's bonding that metal enclosure, right, that box. Then he has the other equipment grounds. He has to bring them all together because they're splicing in the box. And when he does that, he could have done that on put a wire nut on them or whatnot and that type of thing. But he's working really hard to get all of them around screws in the back. He doesn't have to. He can do just one, and then he could have used that equipment ground to connect to all the other equipment grounds that are in the box. That would have been probably a little bit easier for him. Again, leaving you enough conductor is really important.
Okay, so.
And now his equipment grounds are really,
all these
really
wires
short.
are attached, held into the clamp in the receptacle box. So I'd like to take
switch box.
The ones from the bottom.
That's a switch box, my brother. You said that twice.
Nice
I get
bend
it.
in there.
But it's switch
and
box.
Stuff them in as far as you can, so they're not going to get.
And let me give you another tip right here. If you're doing this, go on and make up your neutrals right away. Okay. Go on and make up everything that you need to make up so that when you come back to do the finish and sheetrock's up or gypsum board's up, you're pulling them out, go on and make it so all you got to do is put on your switch. That's it. It just makes it a little easier. Again, is it wrong to do it this way? No, but I'm just giving you tips. For me, I want to make up all my switches. I want to get that out of the way. I want to get all my neutrals tied together, my equipment grounds ready with the pigtail if necessary. I want to get it all done. Now, this is a metal box with a metal strap on a switch. And he bonded the metal of the box in the back. Doesn't necessarily have to take the equipment ground to the switch. If the switch is making contact with the metal box through the 632s, then it's okay because the allowance in the code allows that under 404.9. So again, I think it's B, 404.9B. So again, there's different ways to do this, but I like to make up all of my terminations in a box before I move on.
Disrupted by the drywallers. They have a special tool to turn the drywall around the electrical box, but it involves navigating by sticking it in here first to find an edge, and then jumping it around and then going around the perimeter of the box. When they stick that in, sometimes they grind these wires and will ruin them. And again, that's why the service loop and why you want to tuck them in. Okay, so we're at our first plug location. Again, when I was running the wires through, I've got these loops. To start, just...
Even his side cutters are coated.
Cut off your loop end.
This is a way to make sure you give
in the center there,
no manufacturer any props.
That you will never get straightened back out. So just come in a little bit. Again, I use my knife handle as a guideline. Right in there like that.
Be careful. All right, I don't see any paper, so this tells me, ooh, I hate when he does that. This tells me this is Canada. Okay.
Line it up again.
If it's the US, then you're going to have paper inside of that MMB.
Okay, so I've got my wire jackets off. Again, I'm going to take out these tabs on top of the box.
Now, does that mean that a manufacturer could not make it in the US without paper? Absolutely, we can. But most of us are going to use the paper because when you extrude it, the sheathing would sink down in the interstices between the conductors, and it's not what you want. Although this looks like this sinks down pretty good. So a manufacturer in the US could do this exactly same thing, but more often than not, ours all have paper in it. So that keeps it uniformed around, where you don't see these indentions like you see here. But it is permitted in the standard to do it paperless. But I could tell by this, and because of the name he called it, I could tell this is Canada. But all the U.S. references still apply, just so you know.
Okay, so basically this wire here is the one from the home run feed. This one is going to the next plug. I like to keep them in order, so I just kind of, I don't know, it's just good practice. You know what's going on.
Well, also, since you stapled that one on the inside of the two staples, it would look better if it runs down and the other one lays on top of it, because other than that, it kind of gets all wonky. Of course, he's going to put a loop in it anyway, I'm sure. So
fish them through.
There's nothing wrong with the loop, again, as long as it's not more than 18 inches from the point it enters the box to the first
quarter-inch jacket sticking through. Clamp down. Make sure you're good and tight. Separate your jacketed wires up so you can get your grounds on.
Again, I only have to do one ground. I could twist the two grounds together after I did the one if I wanted, because all that's doing is reducing the length of my equipment ground. But that's his choice. You got the two screws back there? Go for it. That's another misconception that people have, is that screw in the back, they think that it's supposed to be green. The green screw is on the device requirement. The other green screws you run into is the main bonding jumper in a panel. When it's a screw type, then in 250-28, then that would be a green finish screw. Here, they don't have to be green and finish to have a screw that bonds to the back of the box. Do they make green ones? Yes. These are built into the box. That's what it's intended for. It doesn't have to be green. So again, many people say, oh, it's not green. It's okay. At this point, they're nifty, but because his wires are so short, I probably would not. I would probably use one of them, but I would have longer equipment grounds so that I could go around it. Then I have it coming off so that I can then at that point twist them together with a pigtail to go to my device. That's just me.
Tighten your ground down.
And now that box is bonded. Okay.
There we go, all tucked in for safety. Clean up your loop a little bit. And that's plug roughed in.
Are you tired of seeing
All right. Commercials. All right. How's it going so far? Not doing too awful bad. Not really anything to get all crazy about, but definitely some advice for him. Another commercial. Boy, there's some serious commercials that he's running here. So, all right. So it looks like to me that we finished on that one. So again, let's come back to me. And he didn't give anything beyond that. So that's about where he stopped. Not all that bad. If I have to give the guy an installation rating, like I usually do, I'm going to give him probably about a 6, maybe even a 7. Not that bad. It's Canada versus US. He did fine. Again, spacing, make it work out. Again, just be aware of luminaires in the ceiling under the 2020 National Electrical Code that they probably have to be rated to support a ceiling fan. We looked at that. Staples, again, don't drive them so deep that they go into the sheathing. Just stop shy of the sheathing. It's just there to hold it in place. If you bore any holes, make sure that the edge of that hole is at least 1.25 inches away from the edge of the framing member. Otherwise, you're going to have to put a nail plate up there. Those little things. Leave your conductors. Remember, 300.14 says that I have to have at least 6 inches from the point that it exits the sheathing. If you were dealing with raceways, it would be the point that it exits the raceway. If the dimensions of the box itself is anything in any dimension that is less than 8 inches, whether it's from point to point or diagonally, then I have to make sure that even though I have to have that 6 inches, it also has to extend out at least 3 inches beyond the front. That gives you enough room to work with it. And if you give yourself 6 inches on those small boxes, you're probably inherently going to have 3 inches out anyway. Just things to think about. Think about whether or not you want to use plastic boxes versus metal boxes, save you that bonding. All that type of stuff. Now, the only benefit is if you bond the box that are metal boxes with the equipment ground, then you might not need a jumper over to the switch because the switch, if it's grounding type, will go down into actually to the metal in the box. And that's what we saw in 404.9b. Okay, there's a 1 and a 2. Okay, if it's a non-metallic box, you're going to have jumpers over to the switch. But if not, you have some allowances to not have to have an equipment bonding jumper over to the switch. Different things to think about in your layout. Heights, keep it consistent throughout the dwelling. If he's using a certain height, 46 or whatever he was using, make sure that's what you're doing throughout the rest of the house. Otherwise, stay consistent. Just little things like that. Other than that, not that bad of an install. Definitely decent for a do-it-yourselfer. Okay, so that's it. Hopefully you got something out of that. Hope the commentary helped you a little bit in your DIY job. Again, it's not always blunders that are real embarrassing. Sometimes it's just added commentary and assistance in an install. So till next time, stay safe. God bless.